Hi everyone, and welcome to this video on our discussion in measuring the degrees of risk aversion, or essentially measuring risk aversion. And this is part of our overall module on financial decision making under uncertainty. So if you recall from the past video, we discussed the concept of insurances, and we said that insurances are there such that risk-averse individuals can potentially mitigate the risk or eliminate it altogether. Now, of course, this beggars the question, right? How much insurance would particular people be willing to pay for them to be shielded against a risky prospect or a bad outcome? Well, to answer that question, as I inferred in the last video, well, it could be based probably on their degree of risk aversion. But we don't really know how to measure risk aversion, at least not until this video. So in this video, it's going to be all about trying to measure, or at least the theories that have been posited to measure the degree of risk aversion. And we're going to show an actual example using calculus when we discuss it. So what's this desire to measure risk aversion? Well, of course, we would want to quantitatively measure the degree of an individual or an investor's aversion to risk. So we all know that in various investors may not have the exact same risk profile as other investors. And essentially what I would want to do, even as an investor, more importantly as like an insurance company, would be trying to accurately measure the degree of risk aversion of a particular individual. And such a quantitative measure will allow us to compare one investor to another investor, or compare a multitude of investors and judge who is more risk averse than other investors. And knowing whether one investor is more risk averse than another it requires understanding their degree of risk aversion. And because the degree of risk aversion has a direct application on the total value, as we said in the last video, of how much an individual is willing to pay for insurance, or the person's willingness to pay for a particular insurance instrument or a certainty equivalent. So those have underpinnings there, right? So this is the reason why we want to analyze what the degree of risk aversion is. So in this video, we're going to posit two measures, and both were formulated by Arrow and Pratt. So we have our two measures that we will put to place. So the first one is the Arrow-Pratt measure of absolute risk aversion. So note the word absolute. So the Arrow-Pratt measure of absolute risk aversion is a measure of investor reaction to uncertainty or risk relating to changes in the individual's absolute level. Okay, so note the word absolute is key here, of initial wealth. And you can calculate the Arrow-Pratt measure, which is AW. So AW is your Arrow-Pratt measure, as this form here. So it's the second order derivative of the utility function divided by the first order derivative of the utility function. Now, note that we know that this second order derivative is always negative, right? Because the consumer is risk averse. This derivative here is always positive because the consumer prefers more wealth to less wealth. Therefore, if we have the minus sign times a minus, that's a positive divided by a positive. Therefore, this amount here will always be positive. Now, the value of the absolute risk aversion measure can potentially be different for each level of W. And this is why we refer to it as a local measure of risk aversion. Well, what do I mean by this? Well, say you want to compare two different investors on their degree of risk aversion. You can use the Arrow-Pratt absolute risk aversion measure like really well if the two investors have the same level of wealth. But if they don't have the same level of wealth, then potentially you could see some biasness that is there, or something in the estimation that could potentially lead you astray. So there are things that you need to control for. So this is what I said earlier, right? Because this part here is positive, this part here is negative and you multiply it by a negative, this means that the measure is positive for such individuals. Now, it can be shown that if, say you were comparing two people and their degree of risk aversion, their AW is higher for one investor than another, assuming the same level of wealth, then the first investor in this case, since we have this inequality here, is more risk averse than the second investor, and we append the term in an absolute sense. Okay, so that's the restriction that we place there. Now, this measure essentially allows us to appropriately answer the following questions. Well, given two individuals with the same level of current wealth, so say we have two investors, both of them same level of initial wealth, they only differ in their degree of risk aversion, I could answer the question, which of these two individuals would be willing to give up more money for some sure amount of his wealth to avoid a risky prospect? In essence, who would be willing to pay more for insurance between these two? Assuming they have the same level of wealth, who would be willing to pay more for insurance? And that decision of who's willing to pay more is essentially determined by their degree of risk aversion. So if an investor's wealth increases, another question that we can answer is, if the investor's wealth increases, will I be more or less likely to will it be more or less of that wealth to be put in the risky asset? So will that person be willing to put more of their wealth into riskier assets versus safer waters? So that's another thing that the degree of risk aversion can sort of measure. So that's the first measure. The second measure is same people, but it's your relative risk aversion measure, and this is sort of an extension of the absolute risk aversion. So a measure of the relative risk aversion measure is a measure of investor reaction to uncertainty or risk relating to percentage changes in the individual's absolute level of wealth. And you notice that the formula is very similar. It's just this formula here, this entire thing here with the negative sign is essentially your AW. That's your Arrow-Pratt absolute risk aversion measure. And if you multiply it by W, you get the relative. Okay, you get the relative measure of risk aversion. And because wealth is positive, and we know that AW is positive, then the RW is also going to be positive. Okay, so this is what it means, right? Since RW is greater than 0 for risk-averse individuals, since AW is greater than 0 for such individuals, is a local measure of risk aversion. Now, the same conclusion applies. If the relative measure of risk aversion is greater for one investor than another, with the same wealth, right, then investor 1 is more risk averse than investor 2 in the relative sense, right? In the relative sense. Moreover, if A1 is greater than A2, it should also follow that if I calculate the relative measure of that same investor, it should also follow that R1 should be greater than R2. So it's just the same sort of when I do the conclusions between these two measures of risk aversion, because again, the adjustment is just multiplying by wealth, then the adjustment shouldn't change the ordering. Okay, so that's a property we observe. Okay, so what do these measures allow us to quantify? Well, given to individuals with the same fraction of current wealth. Okay, so now we can deal with fractions of current wealth. It's not just the whole amount of wealth. We can deal with the fractions. So say, if we were zeroing in on, say, two people, and then say we zero in on how they would sort of spend, say, 100 units of currency. Okay, when same fraction, say 100 units of currency is both at risk in these two individuals, and they only differ in their degree of risk of risk aversion, which individual would be willing to give up a greater fraction of his wealth to avoid the risky prospect? Again, which of them would be willing to pay more for the insurance? And the other question would be, if an investor's wealth increases, what happens to the fraction of that wealth as he or she would be willing to, or would he or she be willing to put it in more risky assets? So instead of dealing with whole wealth, you can deal with fraction or proportional changes in the current wealth. Okay, so this is our key interpretations. Okay, so if we have a decreasing AW, okay, then the tendency is to hold more pesos in risky assets. If you have an increasing absolute measure of risk aversion, then it's hold less pesos in risky assets, right? So if the intuitively it makes sense, if the person is less is as wealth increases and the risk aversion measure decreases in absolute terms, then the person is willing to put more money into riskier securities because according to that measure, at least he or she wouldn't be needing additional dollars to for him or her to use to compensate, to buy insurance, to shield that risky prospect because the measure is going down. If however the measure is going up, then the person would likely hold more pesos, more in safer securities and less pesos in risky assets. If the AW is constant, then holds the same amount as when we started. So that's for the absolute measure. So this is for AW. Okay, what about for RW? So these are for RW. If the RW is decreasing, then essentially the percentage invested in risky assets increases, right? Because again, you are decreasing the relative risk aversion measure. So if this indicates a decrease in the relative risk aversion measure, then the percentage as of your total investment portfolio which you invest in risky assets increases generally because you wouldn't need again a higher amount to compensate for when you get additional pesos or additional units of currency as income or whatever. Same goes if your RW is increasing, you would hold a lesser percentage in these risky assets. If it's a constant RW, then again, the percentage invested in risky assets remains unchanged. So pretty straightforward and simple interpretations. Okay, so let's have an example of this thing. Okay, so suppose you have an investor with the same utility function as we've been dealing before. So that's W, which is raised to 0.5, W raised to 0.5. What we need to first show is that for all W, the individual prefers more wealth to less wealth, and the person is risk averse. Then we find the Arrow-Pratt measure of absolute risk aversion, then the relative risk aversion measure. And we want to see essentially what we showed in the table in the last slide, what would happen when wealth changes. If I increase wealth, what would happen? Would the investor become more risk averse or less risk averse? And what would be the implication of that, at least based on the interpretations we've seen in the previous slide? So let's start with that. So let's answer one first. One is just about, so we need to show, okay, show that when W is greater than 0, A is prefer more wealth to less wealth. So how do we prove that? More wealth to less wealth. Then B is risk averse, right? And we need to show that the person is risk averse. Is how do we prove that? Well, A is just simple. A is just, you just need to prove that DUW, right, is just positive, which just essentially translates into the first order derivative being greater than 0. So we just need to prove that. If you have a utility function equal to W raised to 0.5, therefore you have this one, DUW over DW is just going to be 0.5W, right? You take the derivative of that with respect to W, that's 0.5W raised to negative 0.5, which is just going to be equal to 0.5 over W raised to 0.5, which is greater than 0 for all W greater than 0. Hence, the individual prefers more wealth to less wealth, right? So that's the answer for that. To prove that the person is risk averse, well, we just need to solve for the second order derivative. So that's D squared UW over DW squared should be less than 0. And this is just equal to, the U double prime W being less than 0. Okay, so let's solve for that. So that's D squared UW, second order derivative with respect to W. So we just take the derivative of this since that was the first order derivative. So negative 0.5 times 0.5, that's negative 0.25. W, negative 0.5 minus 1, that's negative 1.5. You get negative 0.25 over W, 1.5, which is less than 0 for all W greater than 0. Okay, then that implies that the individual is risk averse. Okay, so Now we actually have the components of what comprises the Arrow-Pratt absolute and relative risk aversion measures, right? Because we need this one and this one for that, so we can compute for them. Okay, so second one is let's find AW, right? And let's find AW, and AW, which is your Arrow-Pratt measure of absolute risk aversion, is just equal to the negative of U double prime W, or the second order derivative, divided by the first order derivative. So let's solve for that one. Okay, so that's AW is equal to, okay, negative, okay, our first order derivative is 0. I'm sorry, it's going to be the second order derivative on top. That's negative 0.25 over W raised to 1.5 over, excuse me, that's 0.5 over W raised to 0.5. That's the first order derivative. Then if you simplify this one, you should get, so the negative here and the negative here cancel out. Negative times a negative is just positive 1. So you get 0.25 over W raised to 1.5 times, okay, so you take the reciprocal of this, reciprocal of that in the denominator. So you could divide two fractions. You get W raised to 0.5 over 0.5, right? Over 0.5. So you're going to be left with, if you do this one, okay, so if we sort of simplify this one, okay, this will just be equal to 0.5 over W, right? So if we cancel this one out, okay, so this one will just become 1. And if we simplify that, that becomes 0.5, okay, because 0.25 is half of 0.5. So this is our Arrow-Pratt measure of absolute risk aversion. Okay, now the third question is find the relative risk aversion measure. So number 3, okay, number 3, find, okay, RW. And we know that RW is just equal to AW times W, right? So that's simple enough. Okay, so we have RW is equal to AW, that's 0.5 over W times W, which is just equal to 0.5. Therefore, RW is just equal to 0.5. And that is your relative measure of risk aversion, your Arrow-Pratt relative measure of risk aversion. Okay, so that's 1 to 3. So let's just go back to the fourth question so that we can understand it before we answer it. Okay, so what happens to this investor's degree of absolute risk aversion when wealth increases? So we need to essentially answer this. That's DAW over DW. Okay, and what would that be? Okay, now the next one is how about the degree of relative risk aversion? So this is just DRW over DW, right? And what we're gonna do is we're gonna use our results in 2 and 3 to know that, and then we'll use words to try and interpret that. So that's what we're looking for. Okay, so let's do that. Okay, so 4. Okay, 4 is what happens to the degree of absolute risk aversion. So let's 4A first. So that's DAW over DW. So remember, if we take the derivative, okay, we're going to take the derivative of this with respect to W. So that's 0.5 over W. This is just going to be equal to, okay, if I take the derivative of this, right, that's just going to be equal to negative 0.5 over W squared. That's negative 0.5 over something that is positive. So this one is going to be negative. So this implies that DAW over DW is less than 0 for all W greater than 0. And what's the implication of this? Okay, so it implies that as wealth increases, the investor's degree of absolute risk aversion decreases. Okay. And if you recall the table from earlier, if the person's absolute risk aversion condition is decreasing, then he or she is willing to hold more pesos. So because it's decreasing, decreasing, individual willing to hold more is willing to hold more assets in risky investments. Okay, so that's that. Then the next one is for B. The second one is we need to determine what happens to the relative risk aversion measure. So that's D RW over DW, and that's just equal to what's the derivative of 0.5 with respect to W. That's just going to be equal to 0, right? Because the derivative of a constant with respect to W is just 0 because the constant isn't there. So this implies, which is equal to 0, right? So this implies that dRW over dW is equal to 0 for all W greater than 0. So what does this imply, right? So it implies that as wealth increases, the investors degree of relative risk aversion is unchanged. Okay, so what does that mean? Okay, economically speaking, well, we'll go back to the table. So we have a constant RW, right? So it means that the percentage invested in risky assets is unchanged. So that's what it means. So percentage invested in risky assets remains unchanged. Okay. And that ends our discussion on the two measures of risk aversion. And essentially, those are concepts that we're gonna start to bring together. So in the next video, we're gonna bring all of these concepts together into one sort of unified framework together with a concept we're gonna further discuss, which is the certainty equivalence. So thank you for your attention in this video, and I'll see you in the next one. Thank you very much for paying along.